Heart attacks are usually the result of inflammatory changes in the arteries around the heart. They are among the leading causes of death in the Western world. Can periodontitis or other inflammatory conditions of the mouth affect the development and course of other diseases such as atherosclerosis or diabetes? Periodontitis is caused by bacteria that trigger a destructive inflammatory response in the periodontal tissues which surround and support the teeth. This results in the formation of periodontal pockets lined by ulcers around the roots of the teeth. The total area of this ulcerated wound can range from 5 square centimeters up to 20 square centimeters, about the size of the palm of a hand. Periodontal bacteria repeatedly enter the blood vessels of the gingiva through the ulcerated areas, e.g. when eating or brushing. Locally produced inflammatory substances are also released into the bloodstream. Bacteria and inflammatory substances spread throughout the entire body. Periodontitis can thus have an impact on the health of important organs located far from the oral cavity. Some bacteria can penetrate the endothelial cells that line the blood vessels. Well hidden from the immune system, these bacteria can multiply and infect other cells of the vascular wall, the endothelial cells. The endothelial cells recognize the bacteria, and in response they produce substances that promote inflammation and create further contact points on the cell surfaces. This attracts blood cells, monocytes, which then bind to the endothelial cells. Some infected endothelial cells subsequently die, and the blood vessels lose their elasticity. This so-called endothelial dysfunction is the first stage of atherosclerosis. The next step in the development of atherosclerosis is the formation of so-called fatty streaks. Some white blood cells travel into the vessel wall and differentiate into macrophages. By absorbing harmful cholesterol, they turn into foam cells. Periodontal bacteria promote this process, leading to even more fatty deposits in the blood vessel walls. The foam cells die off gradually, forming a dead core within the fatty deposits, which becomes even larger as other immune cells like T lymphocytes are added. The narrowing of the artery reduces the blood flow. The affected tissues, specifically the heart tissue in the case of the coronary arteries, do not receive enough nutrients or oxygen. Bacteria that cause periodontitis additionally promote the emergence of substances that attack the underlying connective tissue. As a result of the tissue damage, the vascular deposits eventually break up, leaving a wound where blood coagulation takes place. A blood clot develops. This clot further narrows the blood vessel and may even cause complete closure. A heart attack or stroke may occur as a result. The inflammatory substances produced by the damaged endothelial cells are spread throughout the body by way of the bloodstream. The periodontal bacteria in the blood cause a generalized inflammatory response, which further stimulates the progression of atherosclerosis. The general inflammatory reaction triggered by periodontitis can also affect the regulation of blood sugar, glucose. The high sugar causes the pancreas to produce insulin to reduce blood sugar. Normally, insulin receptors bind to the hormone insulin when it appears in the blood. The binding of insulin to these receptors allows the sugar to be transported into the cells. The sugar contained in the bloodstream after a meal is thus absorbed inside cells where it is processed for energy or storage, and the blood sugar level drops. In the presence of generalized inflammation, substances are formed that interfere with this mechanism. They inhibit the binding of insulin and reduce the sugar uptake into the cell. The blood sugar level remains elevated. The inflammatory substances that are formed during periodontitis seem to play a special role. A severe case of periodontitis may cause elevated blood sugar levels even in the absence of diabetes, leading to so-called insulin resistance, a situation in which the body's cells no longer respond to the messengers. If diabetes is already present, periodontitis makes it difficult to control blood sugar levels and increases the risk of late complications of diabetes, such as kidney and heart disease. Conversely, diabetes can contribute to the deterioration of the patient's periodontal status. Here, chemical compounds made of sugar and protein molecules play a role. The sugar in the blood, for example, binds to the hemoglobin in the red blood cells that transport oxygen. The relative amount of the resulting chemical compounds is important for the diagnosis and management of diabetes. If blood sugar levels stay high, other proteins will also start binding the excess sugar. This results in so-called AGEs that promote inflammatory complications such as periodontitis in different ways. For example, AGEs cross-link the fibers of the connective tissue. This makes tissue remodeling more difficult and interferes with wound healing in the oral cavity and elsewhere. AGEs are recognized by the body's cells, such as white blood cells or the cells of the vascular wall. This triggers the formation of messengers tending to cause inflammation. These messengers summon inflammatory cells while disturbing the wound healing process. Both factors accelerate the destruction of periodontal tissues. Research has shown that periodontitis, as well as smoking, high blood pressure, and high blood lipid or fat levels, are risk factors for cardiovascular diseases. In the case of diabetes, the two diseases may amplify one another. The successful treatment of periodontitis can therefore improve not only oral health, but also general health throughout the body. This is particularly true of endothelial dysfunction, which is the first step in the development of atherosclerosis, and which improves with successful periodontal therapy. In many cases, the successful fight against periodontitis also improves blood sugar levels as well as blood fat levels. The key to this success is a reduction of inflammatory substances in the blood, an important step toward breaking the vicious cycle of inflammation in the body.